Good afternoon, everyone. Welcome to the BDTI Skills Studio. Today we have a very interesting session lined up for you. We'll be discussing geospatial analytics, and we'll be following a use case analyzing crime rates. If you attended any sessions, any of our data analytics webinars in the past, this one will be of particular interest, but it is beginner friendly, so everybody will find it approachable and engaging. So just a quick run through the agenda for the day. We will have a quick introduction to BDTI, then we'll jump into our geospatial analytics workshop. We'll have time for a short Q&A and then we'll wrap things up. And please do participate in the chat during the session, sharing your thoughts and asking questions. Share what you learned today with your network and invite them to future sessions. We have a full calendar of events in the next few months, so do be sure to register for upcoming workshops. I'll now hand the floor over to my colleague, Maria Claudia, who will give you an introduction to BDTI, the Big Data Test Infrastructure. Enjoy the workshop.
Hi, everyone. Thanks a lot, Kim, for the nice intro. So let's move forward to the content of this webinar that is really exciting. But first, we need to give a bit of background about our initiative, that is the Big Data Test Infrastructure. So basically, this is a part of the Digital Euro program. It is a specific program to support public administration, public servants. Many of you are working in public institutions. And the idea behind this program is to give an infrastructure that is completely free and it's also completely based on open source tools. We are providing this to public administration for a duration of 6 months. And once you submit your idea, so basically maybe your challenge, the business problem that you want to solve using your open data, we are going to prepare this infrastructure for you, and this is going to be ready in few days. And finally, you can start having fun without, wasting time in configuring tools, infrastructure. Everything is ready. Everything is already working in the cloud, and you just really need to collect your best ingredients, match this with our tools, and start creating something that is for public good. So if you go to the next slide, this is a little bit more, I would say, concrete. In this slide, you can see the main 5 steps. These are very common steps if you are trying to approach a data project. So usually you have the collection phase, then you go start processing your data, and then of course you start analyzing them based on your inputs, also based on your questions. And finally, based on the audience that you want to target, you will create, probably you are going to create a visualization, a dashboard, some widgets, and finally serve your, let's say, your creation to your final, maybe stakeholders, public servant, public administrator, it depends. So ideally, you can find these different steps, and in our Big Data Test Infrastructure, BDTI, you can also choose between many tools. All of them are open source. Why? Because of course we are really pushing forward for open source, and also because we want to have sustainable solution. So you can re-implement the same infrastructure in your own environment. You see here there are a big variety of solutions, from data lakes to database to advanced processing engineering, and also tools for development. That's something that you can also have a deep dive looking at our website. In the service catalog page, you have all the details with all the information about these tools. Then if you move to the next slide, thanks a lot. Let's clarify our audience. So who is the Big Data Test Infrastructure for? First, public administration. So if you are part or you are collaborating with the public administration, and it doesn't matter if it is a small municipality or a big one, or a big maybe ministry, you can apply for the Big Data Test Infrastructure. So the only requirement is this one, to be a European public administration. Then in order to help, also to contribute together to a successful pilot, we highly recommend to have connection maybe with students and people from maybe from academia or from GovTech startups, spin-off from a university. So it's going to be a very nice journey altogether, because you, maybe from the public sector administration, have a more clear view about the business goal you want to achieve. And on the other side, if you don't have enough technical skills in your team, you can rely on geek students and people that want to contribute to the creation of something that is really for the public good. So in case you want to apply for this, please check our website and have a look to our different contents and also stories. Then moving forward, we summarize in this slide just 3 of our last use cases, current pilots that we are running together with public administration. And you can see we have something also very different in terms of, I would say, domain areas. There is one great example from Turku, Finland, where the focus is about transportation. So urban insights and how to make citizen life easier, analyzing data about transportation. Then there is another very super cool example from Germany, Bochum. The city of Bochum is really trying to create a machine learning model using our playground, our big database infrastructure, and is collecting IoT data, so from sensors that are on the trees in the city. So to understand the condition of the trees, also how to forecast some specific information for the public administration and citizen. Finally, one of the last entry is a pilot from Napoli, from Italy, and this one is also about mobility and urban insights. So these are just few of the example you can imagine. And again, it's up to you to use your creativity to define an interesting use case that is going to be implemented in this infrastructure, that it's completely free. Thank you. Then I think if you go to the next slide, this is just very short description of the process, how to apply. This process is really light. It's basically about submitting a template. You can find this template on our website, where you need to describe a bit about your project, about what you want to develop. After you submit your pilot request, we're going to check this request. We're going to set up a meeting with you. And then after we are, let's say, all aligned and we accept your proposal, maximum in 2 weeks, you are going to have the environment ready to use. And in this environment, we can have users from the public administration, but also people, for example, from academia or spin-off or companies that are they want to help you in the development. Okay, thank you. If we go to the next one, I think now it's really the time to start the webinar. Today is going to be extremely interesting. We are going to discuss about geospatial analytics, geodata in general, that is one of the most emerging trends in a data-driven public sector. So thanks a lot, and good luck, Elizabeth, and enjoy the session.
All right, thank you, Maria Claudia. Okay, so yeah, hi everyone. I just want to really quickly introduce myself. I'm Elizabeth. I'm a data scientist working at NIME. And as already introduced, I will talk about geospatial analytics today. It will be an introductory workshop, and I will be introducing the low-code solution with NIME Analytics platform. So what are we going to talk or cover in this workshop? So first, I want to introduce a little bit of theoretical background. I want to talk about Geographic Information Systems, what it is, and why it's useful and why we need it, and highlight some GIS application use cases I'm pretty sure you might have heard about already. At least one or the other. I will also talk about geospatial data types, and then the main focus will be on this geospatial analytics extension for NIME. So NIME Analytics platform, open source and low-code tool. I want to show how to do geospatial analytics low-code with NIME. So actually no code. You don't need to write any code. I also want to show you the workflow in IAM Analytics platform itself. So demo a little bit to you how to configure it, how to use it. All right. Yes, I think with that being said, let's start. So what are Geographic Information Systems, or GIS for short? So GIS stands for Geographic Information Systems, and it basically can be seen as the fundamental approach for geospatial analytics or geospatial analysis. So traditionally, GIS are smart interactive maps, like in a traditional sense. So if you think of GIS, you probably think of an interactive map, let's say OpenStreetMap, you probably know or heard of it already. And you can interact with the map. It can answer you questions. It can, for example, tell you the shortest way from point A to point B if you're using a car or if you're using a bike, and so on and so forth. So this is like in the traditional sense, a GIS application or GIS. However, in reality, such GIS applications or interactive maps, they are powered by a huge set of tools and procedures behind that. So rather, GIS can be seen as a computer system to perform the task of geospatial analysis. And more precisely, it's for capturing, storing, checking, and visualizing geospatial data. So I will talk about geodata in more detail later, but just in general, geospatial data is any kind of data that is somehow related to positions on the Earth's surface. So all in all, GIS provides a framework to organize our knowledge, our geographical knowledge, and it helps us to reveal pattern, relationships, and processes. So with GIS, we can broaden our knowledge, we can deepen our understanding of the whole world, actually, because we are using this geographical data. And just one example for a GIS application would be Quantum GIS or QGIS. It's an open source tool offered by or through the BDTI framework. You can see an example how it looks here in this slide. So it is basically to create, edit, visualize, analyze, and publish geospatial informations. The language here used under, like when you work with it, would be C++ or Python. So it's a code-based GIS application, and because of that, you can have access to an extensive library of plugins. You can do advanced data visualizations with it. It supports numerous data formats. You can integrate with other GIS applications and other spatial data tools. And yeah, it's also highly customizable. So this is one of the examples which you have access to through the BDTI framework. Now, in the bigger picture, just to sum it all up, the overall aim of GIS is to examine spatial relationships, patterns, and trends. So it's to improve the efficiency at all kinds of application areas. And well, with that, we hope to make a difference in the world. Now, the importance of GIS. So why is GIS so powerful and useful? So I think in order to understand the importance of GIS, maybe we can talk a little bit about the historical part as well. GIS emerged roughly within the last, let's say, 50 years. Not only GIS, geospatial analysis, it's a relatively new field, and it mainly started to take off in the 1990s. This is when companies and governments started to being able to access and create the data that is needed for geographic information systems. So very back in the days, it was a one-person thing. Usually you had like one GIS tool somewhere accessible for one person. With the more usage of smartphones and internet and cloud-based solutions, it evolved. So nowadays, all of us actually have access to GIS applications. I mentioned already thinking about interactive maps like OpenStreetMap. We have smartphones, and I'm pretty sure every one of you has one of such an interactive map somewhere on their smartphone, and also other GIS data. So just given the fact that everyone is now able to access it is already like one reason for why it's so powerful and important. However, if we're looking at the challenges we are facing today, like those modern challenges we have, thinking about climate change, thinking about challenges in public health sector or public health related challenges, be it like monitoring water quality or I mean, very common example, but when we had the COVID outbreak, managing or analyzing, visualizing how such a virus would spread in a world that we have today, which is so connected, like everyone's so connected with everyone. All those issues basically need complex systems to be addressed. When we're talking about smart mobility, when to find out where to build new transportation systems or what kind of transportation systems is the best. So this is all things and challenges we're facing today that are important and that are related to GIS. And yeah, with that, I'm just saying that I want to talk about a few applications later as well. I just want to talk about it because I want to highlight it's so present and it's so important. So yeah, GIS is an kind of like all rounder, let's say like that. You find it in all kind of research areas. Now, with GIS, as I said, we're not only able to deepen like the understanding of a world and like understand some like distances or stuff like that, but we can also actually conceptualize, represent, and communicate our ideas. And what's also quite a factor is that we can, with GIS, we can reconstruct historical things that happened in the past as we have the data recorded, for example. We can illustrate, obviously, the present, but we could also plan the future with like forecastings, or even combine all those three things, or let's say we can illustrate the present and reconstruct history to plan for future things that might be happened, like, for example, climate change models. Now, another thing about GIS is that in general, when we go a bit more into the materia, there are basically 4 components or main functions GIS has, and I just want to quickly go through all of them because all of them are together important for GIS. So the first component is data management. This is about organizing, storing, retrieving, and maintaining geospatial data. In general, geospatial data has 2 data types, which is vector data and raster data. I'll come back to that later and like talk about it in more detail. But the data management is very important because without geospatial data, there is no geographic information systems. So it's quite obvious why data management part is so important, self-explanatory. Also, those GIS data sets are usually quite huge, and yeah, I think those are all reasons why efficient data management is important. Now, another component of GIS is the visualization part. So usually GIS data or geospatial data is visualized on a map. And this helps us providing a context to our geodata. So for example, if you think of coordinates, let's say a coordinate of a city, a latitude and a longitude coordinate, like at least for me, when I just see the coordinate, I don't really have the context where exactly it's located on the Earth, like maybe roughly, yes, but like I don't know all the coordinates of all the cities, obviously. But if you visualize those coordinates on a map, you see where it is located. And from that, you can, for example, derive factors like what's the climate there? Is it close to the ocean? Is it in the mountains? What other bigger cities are around it? What's the urban area we have? So visualizing geospatial data gives us context. And in general, there are, or let's say in general, but there are 3 main or very common visualization types when it comes to geospatial maps, which is first of all, the choropleth map. I have an example here. So a choropleth map represents data values for different subregions in a larger area. So here, it's just one example I pulled from an IM workflow. It's visualized with an IM geospatial view node. You will get to know that node later. This one visualizes the population growth rate in the US for each state. So yeah, just by one look, you can see how each state compares to other states and that on a whole country level. Of course, you can also choose different areas, more fine-graded areas. You could do it for the whole world. On country level, it really depends. Then we have spatial heat maps. So spatial heat maps, they also use like this color shading to represent the intensity or density of certain data values in an area. In this case, we visualized the wildfire density in the state of Washington, and you can clearly see like those areas that are like in this darker red shade are areas where you have more wildfires, where it's more clustered, whereas certain other areas, you just have a few wildfires. So that's the idea behind those spatial heat maps. And lastly, there are also those isoline maps, which are very common, and I think you've already seen that. This one visualizes temperatures. And the idea of those isoline maps is to use contour lines to represent the data, and it connects the points that have a similar data value, like the temperature, and with that, you can easily compare it to the areas that have a different value for temperature in that case. So that's about visualization. And the third component of GIS is, well, the topic we're talking about today, which is geospatial analysis. And here it mainly refers to the software and the knowledge we need to analyze those geographic relationships and patterns. And lastly, the fourth main function or component of GIS is the GIS editing. And this refers to either creating, collecting new geospatial data, so building new data sets. I mean, it's important to continuously, we have like better systems, like everything evolves, everything becomes more precise. So it's important to continue collecting new data when we're able to measure new things, but also it's important to update the existing data we have. So we should maintain the data, the geodata we already have, and make sure it's accurate, up to date, and relevant. So this is the GIS editing part. Now, of course, like with every other area as well, there might be some challenges when we're talking about GIS. I just want to quickly go through it. I don't want to talk about it in too much detail, but when thinking about GIS, we might face some data barriers. And if you have ever tried to find or access a certain geospatial data set or looking for a very specific information, you might realize it's quite hard to find because data sources are often unknown, or they might, like the data might be scattered across many different data sources. Also, data might be restricted or licensed or sensitive. So it's not always so easy to find the data you need. And also, especially if the data contains space and time component as well, it's very big and it might be quite hard to interact with. We also might face tool barriers. So there are different GIS tools out there, and some of them are open source, but others might require a license. So you might face challenges there. Also, specific operating environments might be required, or you might need high computing power. Also, there might be challenges when you maintain your GIS applications. And lastly, there might also be application barriers. This is due to the fact that like GIS applications or tools, they have quite a broad applicability, which is nice because a lot of people with different backgrounds and different technical levels can use it. So it makes it quite accessible. However, there might be this issue. It might be difficult to communicate complex technical issues with those different, well, user backgrounds. So much about those challenges when it's about GIS. And lastly, I want to just talk a little bit about a few GIS applications to maybe just help you get an idea how broad the range, the application range is. And I'm pretty sure, as I said before, the one or the other thing you might have already heard or at least have an idea what it is. So GIS applications are found in the area of urban planning. So for example, you can model and analyze urban land use using geospatial data. You can plan transportation and infrastructure, which all in all helps you to make better decisions, more efficient decisions. Yes. Another application would be in the environmental management. So I already mentioned the topic of the climate change earlier, but this is just one idea. You can also model, use GIS data to model and monitor natural resources, or you can track species habitats. So there are all kind of this different things that are related to environmental management. Also, in emergency management, it's quite useful and used actually. So I mentioned this COVID example earlier. So disease outbreaks. So with GIS data, you can measure and model how fast a virus, for example, spreads across the globe and where it might spread next, or where it might spread faster than compared to other areas. But also just response system to natural disasters. Maybe if you know certain areas that have a higher risk of wildfires, and then together with a weather component, you could use that to well, set up those emergency management systems. And this is actually true for all kinds of emergencies. Also in agriculture, GIS is used. Maybe also a little bit like from a business point of view, farmers could use it to optimize crop yields, or to manage land use. So where to grow what kind of thing, like what kind of plant. Maybe there are certain areas that are more successful or for growing wheat than others, or corn or something. Also, you can monitor soil or water quality. When it comes to energy management, geodata is used. You can optimize energy distribution networks, you can manage energy usage, and identify opportunities for energy conservation. Also quite an up-to-date topic, or quite a modern topic at the moment. And then lastly, because those were all like more, let's say, social science and political science related topics, it's also used just in the businesses. So in the economy, in enterprises. So marketeers actually use GIS data to target their marketing efforts to certain urban areas, demographic areas. They can investigate consumer behavior patterns and then actually, for example, find out in which regions to target advertisement of which products, things like that. Or maybe there are regions where certain products just are not successful at all, so they can take it from the market there. So those would be the business or economy point of view, let's say like that. Okay, so yeah, this is just to give you an idea what GIS data is roughly, what GIS applications are roughly out there. Now let's quickly talk about geospatial data types. I said before there are two main types, vector data and raster data. Now, let's talk about or start with vector data. So vector data, they store parameters that have discrete boundaries, and it's actually the most common spatial data type. And there we distinguish between points, lines, and polygons. Now, a point, it's a distinct point somewhere, and of a point, you cannot really measure any length or area, so it doesn't really have those features. And an example would be the location of a restaurant on a map, for example. This would be a point. Then we have line data. Line data is a one-dimensional linear feature, and of lines, you can actually measure the length. And a very good example is maybe streets, or in this case, what I visualized here is the bike lanes of Brussels. So the city of Brussels, just the bike lanes. And of those, of course, you can measure the length, you can measure distance, and so on. And lastly, we have polygons, which is also vector data, and it's a two-dimensional area. This gives you insights into the area and the perimeter. So here you see, for example, the polygon, so the shape, the area of the city of Brussels. And yeah, you can, well, calculate the size and use it for all other kinds of, transformations. In general, vector data is a high quality representation of geospatial features, and this means you can enlarge it, you can stretch it, or you can reduce it without losing any quality. So this is vector data. Then we have raster data. Raster data, let me already show this example here. Raster data is a matrix of cells where each cell is representing a specific value or a specific geospatial information. An example would be, for example, satellite images or digital elevation models, for example. This example here, I also pulled that from KNIME. And this is a very simple example. This just shows restaurant density in Brussels. So there I divided the city of Brussels in different cells and grids and counted the number of restaurants present in each of these grids. And then you can, like the color coding then indicates where we have more restaurants, which was obviously in the city center compared to more outskirt areas. In general, when we have raster data, there are two types of data we can use or we can visualize with rasters, which is continuous data and discrete data. Now, continuous data, here the cells or the values in the cells, they change gradually given a fixed representative value or a fixed registration. For example, those digital elevation models, they use the sea level as like the reference point, and then each cell is representing elevation either above or below sea level, so related to this registration point. Now, discrete data, here, this map I showed you on the right would be an example for discrete data. Here, the grid cells can only take a specific value and they are well defined. So yeah, here you just have the number of restaurants in each cell. And compared to vector data, this raster data is not scalable. So if you enlarge it or stretch it, it might pixelate or distort. And now there's like this third kind of geodata type, which is geo-temporal data. Geo-temporal data is a combination of vector or raster data with this temporal component. Here you see an example. Here you see the number of tweets tweeted at their location at a given point in time. And it's like this, I just added this as a GIF here that you can see that at a certain day in September, the number of tweets posted spiked. So there were more tweets on those 1 or 2 days. And this would be an example for geotemporal data. But depending on the data type, there can be tons of different applications. The progression of a vehicle over time would also be geotemporal data, for example. All right. With that, I have shared a little bit of theoretical background. We now learned what is GIS, what are common GIS applications, what are the geospatial data types. But next, what I now want to show you is, or introduce to you, is this geospatial analytic extension for KNIME, which I said before is a low-code way or no-code way how to do geospatial analysis from within KNIME Analytics platform. So maybe first, as a very, very short recap, what is KNIME Analytics platform? For those who don't know, it's a open source low-code tool with which you can, work with the data in all kinds of ways. So it's basically a tool to make sense of your data. You can use it to transform your data, to access data, to visualize it, to create reportings. It's really, it has a huge application range, and it's for all kinds of data workers. If you're a data analyst, a data scientist, a data engineer, it doesn't matter. Everyone will have their benefits of using KNIME and have options what to do with KNIME. When I say no code, I mean it has this visual interface, so you don't have to write any sort of code, no Python, no Java, nothing. And what is important, KNIME Analytics platform is part of the BDTI service offering. So if you have access to that, you will also have access to KNIME Analytics platform. So in KNIME, we work with those so-called nodes. Those are those little colored icons, let's say it like that, those boxes, and each node performs exactly one task. And then when you add together, when you add together multiple nodes next to each other, you step-by-step build your workflow. And this is overall the general idea of how KNIME works. And also then the data flows through your nodes, basically node by node. So you have a stepwise execution if you want. Now, this geospatial analytics extension, it's one of our community extensions. It was developed by the Center for Geographic Analysis by Harvard University, together with NIME. It's available since 2 years now, roughly 1.5, 2 years, and it contains more than 60 nodes with which you can do low-code geospatial analysis. You can write and read geospatial files. You can perform spatial calculations, transformations, different conversions. You can visualize GIS data with interactive maps. And also this extension is accessible through the BDTI service offering. So you can also use that. So in the next couple of slides, I want to highlight a few functions of this geospatial analytics extension before going into the use case of today and the workflow. So yes, what can you do with this extension? You can access geospatial data. We have dedicated reader nodes. When you read in, so usually geospatial data is stored either in a GeoJSON or in a shapefile or even GeoPackage or zipped shapefile. So it's usually not stored as an Excel or CSV file. So we have those dedicated reader nodes for that. And if you read in your data with NIME, you will get the data in the NIME table format, but we have a specific geometry data type just for this geodata. So this is when you have a file. However, you can also access open data sets from within NIME, for example, OpenStreetMap. We have a node for collecting boundaries from OpenStreetMap or road networks. Also, there is a node to collect census data or access census data. So there are different ways to access open data sets. Here's just one example with the OSM boundary map node. Just an idea how it works. You just input a place name, whatever you want, and then it retrieves you this this data you see down here. It's some, geospatial data or geometry data. It gets us the polygon of the input location, so the area, but also gives us, for example, the coordinates as the representative point. So this is when you want to access GIS data. Now, I also said you can do specific spatial transformations. For example, there's a projection node which you can use to transform your data from one coordinate reference system to another. This is a bit specific. So, for example, there is a coordinate reference system that uses as a unit degrees. So this is, for example, taking into account the curvature of the Earth. Now, sometimes this is not really what you need or useful for your application. So you can transform to a different CRS, and then the unit is meters. This is basically the idea. It's just to transform, but there are many different coordinate reference systems. So it's to transform those. We have some more transformation options. For example, there's this geometry to point node, which is quite useful if you have a polygon and you want to get a point. So this basically takes either the centroid or the representative point of a geometry, so of a polygon of an area, and outputs it as a point. It's actually, those are quite simple transformations. Same with the polygon to line, for example. You have this boundary or you have this polygon, and when you transform it into a line, you get just the boundary line. So that's another option how to transform geodata within NIME. And similar ideas when you use a line to multipoint node. With that, you can transform a line into many small data points, so a multipoint. So I just showed it to you that you have seen it and that you roughly have an idea what is possible. You can do spatial conversions with the extension. You can transform coordinates into a geometry object, so into a point. There's an example on the slide here. You just have the latitude and longitude, and you get a point, a geometry object out of that. We also have a geocoding node. Geocoding is the idea that you enter an address and it retrieves you the geometry object, so the geospatial position, basically. In this example, I just added or inserted the address of the Zurich NIME office, and well, it outputs me a point. It's the location of our office. So this is the idea behind geocoding. We also have nodes for spatial manipulations. Important one is maybe this buffer node, which transforms a point object into a polygon, which contains the padding space. So, and here, this coordinate reference system I mentioned before might be important because I said one, for example, has degrees as a unit. Other coordinate reference systems have meters. So in this case, what I did, I have my point, or I had a point, and I wanted to draw this area with 5,000 meters around it. This is, I know that it's 5,000 meters because this is based on the coordinate reference systems. If you use a different one, for example, degrees, your output will be completely different, obviously. We can also do a spatial join. This is basically just if you have two geometry objects, well, you join them and then, well, you merge those two tables based on their spatial relation. And lastly, we have, you can calculate distances between points. The hover sign distance I just want to highlight because it calculates the distance between point A and point B, considering the curvature of the Earth. Now, I also promised you visualizations. We have nodes. There are two nodes. One is geospatial view node. It visualizes any kind of geometry object on such an interactive world map. This here is the polygon of Germany, so the area, but it would also visualize points, line strings. It can also visualize different geometry objects within the same map. So if you have points and boundaries, for example, or points and lines, you can visualize both in one view. We also have the Kepler GL GeoView. I just want to mention that it's a bit specific to well, this whole geo topic. It also visualizes those geometry objects on an interactive map, but it refers to this Kepler GL visualization framework. And by that, you can have a bit more, well, sophisticated or a bit more real life visualizations. As you can see here, the two examples. All right, and that is roughly a short overview what this extension, what we can do with the geospatial extension. But I think the best way to maybe give you a bit of a, well, better understanding of the options and capabilities, let's just have a look at this use case I brought today. And well, what I built a geospatial application using NIME analytics platform, and there I visualized and analyzed crime statistics or crime index in Europe. Now, what's the use case? So as I said, I visualized crime numbers. Those are the number of committed crimes which were reported by the police. I have this data for different crime types, and I have the data for different European countries. And yeah, I visualize those on an interactive dashboard and on for different granularity. So on country level and on like for the cities and metropolitan areas. To make this just a bit better for visualization, I calculated the crime index. So I just calculated the number of crimes by 100,000 population. So just to make it comparable and to set it in relation to, well, the population, because of course a city with a higher population might also have a higher number of reported crimes, which, well, makes sense. So yeah, I set this into relation to the population numbers. And here I have a give, which you can see what we want to do. Oh, I'm sorry, what we want to do. So we have those different interactive dashboards. One features a car path map. Another one is more like a bubble chart where you see the crime numbers for each city and metropolitan area for a specific country. And yeah, in the last on this last interactive dashboard, you can actually search for your own location, your own city using this geocoding node, and then see, well, how the numbers look in your city or compared, like the 5 closest cities compared to your input location. So this is the idea, what we want to do. Now let's quickly mention the data. We have data about crime numbers. Those are, as I said, annual numbers. It's the number of committed crimes reported by the police and divided by or distinguished by crime type. We have, so I got this data from Eurostat, and we have the data available for many years. However, I decided to focus on the year 2019, just for the reason that not every year has, so it was the year with the most data available, because there was not in every year was data for each country. So I decided to take the year 2019 as it had the most data entries. The population data I also retrieved from Eurostat. It's just the number of, well, people, total population. I could go by gender and age class, but I didn't do that. I just took the total population for this use case to keep it a bit simple. And of course, also filtered this data to 2019 to make it comparable. And lastly, we also have geodata. There are two kinds of geodata I'm using. One is a GeoJSON file with country boundaries, which I also took from Eurostat, from GISCO. And I also, for the cities, retrieved the coordinates, and those I retrieved from OpenStreetMap, but through the KNIME Analytics platform, which I will show to you later. Now, on a very high-level overview, this is the workflow. This is the entire workflow. If you have never used KNIME before, maybe this looks a bit scary. If you have used KNIME before, I hope it doesn't look that scary anymore. So this is the workflow, and it roughly consists of 5 steps. So step 1 is we need to access our data. Step 2 is the pre-processing. This is not per se relevant for the geospatial task, but well, we still need to bring our data into a comparable format and processes a little to make it easier to retrieve, for example, the coordinates for the cities. But then step 3, 4, and 5, they concentrate on the geoanalysis part. So first is the step 3 is the geospatial analysis on country level, where we create a choropleth map you've seen before. In step 4, we focus on cities and metropolitan areas. So it's a bit of a different kind of geo visualization, just to show you also the different, just the different options. And lastly, this last page was where you could input your own city, and it geocodes your city and finds the coordinate for that, and then shows the crime statistics for your city. This workflow is available in the GitLab repository later for download, so you can download it. You only need to install the geospatial extension, but other than that, this workflow is ready to be executed, and then you can just, well, interact with it yourself. Now, let's have a look at all those steps in more detail. So for the data accessing, we're dealing with Excel data for the crime and population numbers. So here we just use Excel readers. And for the GeoJSON file I use this GeoFile reader I mentioned earlier. So here, well, this is not so much to talk about. So the first step is just to bring your data into KNIME. However, since the data is, well, it needs a bit of like formatting and reshaping. We need to take care of missing values. We need to clean the data. We need to filter the data to the year 2019. And in the end, at some point, we get a data set in KNIME where we joined our crime data, so the total number of committed crimes for each crime type, with the population. And we can see we have those numbers on country level and then on city level. So this is just an extract. In total, we have like, I think 30 countries and 240 or 255 cities. So this is what we do in the data pre-processing step. We also calculate this crime index, as I said before. For that, you can use a MAR formula node in KNIME. But yeah, in the end, you just have a data set and you calculate your crime index, and well, you have the total number of committed crimes in relation to 100,000 population. So it becomes comparable that way. Now, let's talk about this geo part rather. So for the first view I showed you, we have the choropleth map here. So what we need to do is we need to filter our data and add our geo information we have. This is how it would look like. You are using this geospatial view node for that, and I'm happy to show that to you in a second in KNIME. And a similar thing we do for step 4, where we just filter on our metropolitan areas and cities. Here we need a bit more pre-processing. Some of the cities are metropolitan areas, so we had to split those, get the coordinates for each individual city and merge them back together. I will show those in KNIME. But the important part here is I retrieved the coordinate data with this OSM boundary map node. And then to get our geometry column, we have this lat long to geometry node I introduced earlier. This converts our coordinates into a geometry object, and that way, so here you can also see an example in this table. So we have points now, and that way we are able to visualize cities on a map. The idea here is that the size of the circle represents basically the index. So the bigger the circle, the higher is the index, the crime index for the certain crime type. And the color coding is an indicator for the population. So those purple cities have rather lower population. And for example, Brussels with the yellow is quite high populated. All right, and in the last step, I added some interactivity, but I don't want to talk much about that in detail because I just want to focus on the geospatial part. With those widget nodes, we can add interactivity to our charts, which I will show to you in a second in KNIME. All right, and yeah, those are our 2 visualizations. Now, let me jump through that. Now, let me show it to you in KNIME. So what do we have? We have those 3 visualizations. Those are 3 different types of visualizations using one and the same node, the geospatial view node. So I just jumped into KNIME now. This is KNIME Analytics platform. For those who don't know, here in the middle, I zoom out a bit, you have your workflow editor. Here you build your workflow in the middle. Here on the left, so this is really like very high level now, but here on the left, you have a repository with all the nodes, so all the tools, all the tasks you can do with KNIME. Anyways, so this is how KNIME Analytics platform looks like. And this is the workflow I've shown to you on the screenshot. So yeah, as I said, what we do is we read in our data, we filter our data, we join our data, clean and standardize it, and calculate our crime index. And in the end, we have a table like this. I've shown the screenshot already. We have those numbers now. So this is all, let's say, typical or general data analysis. So this is not per se geospatial related. Now the geospatial part comes here at the bottom. So one thing is I'm reading in this geo file, and I have a huge data set with a polygon or multi-polygon for each country in the world. I don't need all of them. I just take the ones, as I do basic and similar VLOOKUP, because I just take the ones of the countries I have present in my data set. And then when I visualize this, you see this view here, and it's quite interactive. So you can change your settings here. And what it does in the background, it updates the setting of the geospatial view node. Now, if we have a look at this geospatial view node, it's inside this component here. And what it allows you to do is to set certain settings. So it takes a geometry column for visualization. And then you can control settings, what to include and exclude for your tooltips or marker pop-ups. You can change the color coding, for example. You have different color maps available. You can change the base map. I use OpenStreetMap, but there are different maps you can access through the node. So this is one idea, and this is kind of like this choropleth map as it's taking the geospatial boundaries. Now, this is about visualizing polygons. The second view I've shown you was on city level. So just maybe to recap that, let's just visualize it for Belgium now. Just to show you again how it looked like. So this was for a specific country, visualized the crime index. Also here you can change what kind of crime type you're interested in, and it updates this geospatial view in the back. Now, how did we do or receive that? So I said before, we retrieved using the OSM boundary map node, we retrieved the coordinates for each city. And so you see that in the table here. So every city now has this, well, latitude and longitude. And then we can just use the lat long to geometry node to open a configuration setting. It's actually quite simple. You just need this latitude and longitude column. You can specify a coordinate reference system here. I just use the default value. It's fine for now for this use case. And what it does, it outputs you or converts you each coordinate into this geometry data type. Then, if we feed this kind of data into our geospatial view node, it will visualize, well, the points. And as I said before, a point is just, well, a point, a specific location on a map. And those are those points for the city. So how did I retrieve this size? So what I did and what I haven't shown before is you can in this node also configure a size, like a column that indicates the size of your geometry object. Now we can, the very basic, let's just sort of very basic or default setting. If you visualize points, you have them probably not super visible, but they are quite small here, right? So this is just the default, like you have a size of a size of 5. You can increase this, of course, and then those circles get bigger. So you can control the size scale just individually. And then it's true for every geometry object, for every point. However, because I wanted to see those differences and visualize somehow the crime index related to population, I used as a marker size column the value, the crime index value. And then it sets those different circles or sizes of the points into relation to each other. And this is how you could, for example, control the size of certain objects or geo objects. So this is also the same view as before, but we are having as a base now points and not polygons anymore. Now, the very last thing I want to show to you is the last page or the last visualization, which was the geocoding. So if I show you, wait, let me show you this high overview again. So this is how it looked on the slides and what I've shown to you. Now, maybe we need to scroll in here. So you see, you can scroll out and in of those maps. So what we do here is we have an input location and we geocode this input location. So you can also enter a different location here. For example, if you go London and then you update your location, it then geocodes London into a point object and then calculates the distance to each of the surrounding, like to the 5 closest cities surrounded by it. you can see it now here in the map. We're now here in London, and the 5 closest cities are actually here in France and 1 in Belgium. So maybe just to wrap this up, how does it work? So I said there is this geocoding node. The geocoding node takes your address. So the address is London, United Kingdom, because we entered that. And then it geocodes this location into this point object here. And then what we can do is we use this hover sign distance to calculate our distance between the input location to every other of our cities in our data set. And in the end, so as I said, hover sign distance uses or considers curvature of the Earth, and yeah, using that, you get the distance in kilometers, which, well, are if you sorted, the 5 closest are the ones shown in the map. And yeah, again, it's a geospatial view node. Again, same node, but yeah, this time we used a different kind of color coding, where we just said that the input location is coded blue and the rest is color coded in red, just to make it easy spottable what are your input location, or what is your input location. And here, for example, I set the marker size scale to 10 for everyone because I don't want different sizes. All right. So yeah, this is another way, or another idea how to visualize different kind of geodata. Right. And I think with that, also with looking at time, I'm quickly jumping back to the slides, because I just want to quickly wrap up the session before we can jump to the Q&A, and I'm happy to answer more questions or also show more in KNIME AP. So just to wrap this up, what have we learned in the last hour? So we talked about GIS, we talked about how it helps with modern challenges in public health, climate change, with smart mobility, and so on and so forth. I've introduced common geospatial types, the 2 most common, or the 2 data types we have, vector data and raster data. I introduced the geospatial analytics extension, with which you can do no-code geospatial analysis. And I showed you how to build in this those dashboards, how you can visualize different types of geodata with KNIME without using any kind of code. Now, if you want to get started with geospatial analysis for KNIME, so I just want to point you to very few resources we have on our KNIME website. There is a geospatial analytics cheat sheet, which contains the most common nodes you need to know. Most of them, or many of them, I've mentioned already, so there you can read it again. And also there are a couple of example workflows provided by the Center for Geographic Analysis from Harvard that is on the KNIME Community Hub, and just some general learning materials. If you want to get started with KNIME in general, we have a learning center, we have a YouTube channel with videos, and the KNIME forum in case you have any very specific questions. And yep, with that, I'm reaching the end, and I'm happy to move on to Q&A if there are any questions. Just as a last thing, the slides, the workflow, all the other things, they are accessible at this BDTI Skills Studio GitLab repository. Here's the link and the QR code to it. And yeah, as I said, the workflow will be shared there. You can download it. It should be ready to be executed. And then you can investigate yourself or play with the interaction a little bit. And yeah, with that, already thanks for your time. I'm reaching the end of my presentation. Thanks for watching, and yeah, I'm happy to answer a couple of questions if there are any. Let me have a look at the chat, or maybe.
Yes, hi Elizabeth, thanks a lot for your presentation. And in the meantime, we are ready to some of the questions, but I think I will encourage participants to type more questions. And there is one that I think we didn't answer. It's specifically about using Sparkle when I'm just scrolling the initial chat. It's about using NIME to process Spark. So basically to process big and huge amount of data. If there are specific Spark building blocks, NIME to use this, not related to your specific example, the question.
Yes, yes, there is. There are different big data frameworks. Basically, we have, and Spark is one of them. I'm not sure, to be honest, at the moment if I installed it. Yeah, I installed it. So there is an extension for that, or integration. You would need to install that to access the nodes, but then you have different kind of nodes, also for other big data environments. So yeah. Also, if you want to connect to databases, for example, we have a database integration. You can access data from remote file systems as well. It doesn't have to be, in my case, it was now just Excel and CSV file, or just 2 Excel files. But yeah, you can access also data from other outside of NIME, so to say, from external data sources.
Okay, great. And if I'm not wrong, there was an initial question that I mean, Roberto already replied. It was about using NIME for GTFS. That is, the standard for transportation and for transit feed specification. And we answer that you can use specific libraries, for example, from Python, in Python, and in R. I just share a link with a lot of resources, and then in NIME you can easily create a new Python block, and you can type the code inside.
Yes.
I have GTF specific building blocks, but maybe I'm wrong.
Yeah. Yes. Right. Yes. There's, for example, this Python integration. Let me just check. I can just pull up this real quick. If you have your own Python code, you could code within this Python script node, for example, and there you can just write your Python code and then run it from within NIME. So yeah, if you have a script already for something. Also with the geospatial stuff, I know that some things you can do, we don't have the nodes yet for, so theoretically you could enhance or upskill your geo workflow with integrating stuff with Python script. Yeah.
Okay, great. And I'm just checking there is a specific section in the WebEx for the future. That is the Q&A. It's going to be a little bit easy if we try to handle the question there. Then there was a specific question about storage and the BDTI options, and you can find very well that documentation in the link that I posted in the chat, where we explain the different option you can have in BDTI. Then, I don't know if you see something else. Please feel free to post your questions. Yes, there is another one. If it's possible to create and share a starter NIME workspace with some preloaded Eurostat GISCO data, like the example, for people to explore and possibly taking out the data discovery access barriers to some early stage users. Yeah, that's a very good idea. So the point, if I understood correctly, is to have a workspace, a NIME workflow that we can maybe share with the users. So we can already upload this in our GitLab repository, where we can already connect the information, the dataset from the GitHub repository from Eurostat, the GISCO one, the one you were using, and to pre-elaborate the geo information. Maybe this, Elizabeth, is something we can discuss later.
Yeah, happy to. Yeah, good idea.
Okay. I see also that I received a private question, but I'm not sure if we already Yes, so the question is if you can clarify the difference between point types of a polygon.
The difference between what, point and polygon?
Mm-hmm.
Yes. Let me go back to this slide. So, I mean, both of those types are vector data. So what a point is literally a point on a map, like the location. If you take latitude and longitude coordinates, you have one specific point somewhere on the Earth. And usually this point also doesn't have a length, it doesn't have an area. It's really just, well, the location of something. Now a polygon, so I was trying to show or visualize that and make it clear by that, a polygon is a two-dimensional area. And in this case, just for the sake of this example, actually, I retrieved the boundary of Brussels from OpenStreetMap. So this is officially the city boundaries, and the polygon is the area covering all of it. And you can, for example, measure the area itself. You can measure the perimeter, or you can also use this area now for further geo analysis. For example, you can now say, okay, I have the area, like this polygon, this part. Let's find all restaurants that belong to this area, for example. So it has some, let's say, geospatial features more than just a point, because yeah, a point is just like one dot. Maybe like, I don't know if that's the ideal comparison, but if you have, for example, consider an image which consists of many pixels. So maybe a data point, like this distinct point, would be one pixel, so to say. And then an area could be more than just that. I mean, it's not the ideal comparison, but maybe just to make it clear.
Yes, it's really useful. And by the way, I just want to comment also that if you're a Python developer, there is an amazing library. It is called GeoPandas. That is specifically to do all these operations that Elizabeth was also performing in 9. And I will post the link to this library that you can use very, very easily. There are a lot of examples. You can use this in Jupyter Notebook, for example, and that's highly recommended. Okay, I think it's time to close. Maybe let's go to the last slide just to wrap up and to share the last updates. Thanks a lot, Elizabeth.
Let's jump through the slides. Oh yeah, here.
Yes, I think you can go maybe one back if I'm not wrong.
One back.
Yes. Q&A. Yes, the next one.
Get this.
Okay, great. So in this slide, you can see all the next webinars we already planned. So feel free to share these amazing opportunities with your colleagues, with your friends, and we are really happy to see so many participants like today. You can also find the description in our website. Then just a small reminder, about BDTI. If you are a public administration, if you are a public servant, if you are really interested in doing something for the public good, that's a great opportunity. So feel free to check the process and then to submit your idea and to set up a meeting with us. Finally, I would say this is our main contact points. This is our website. This is our main functional mailbox. And also, don't forget and subscribe to our amazing newsletter. Thank you very much for your attention. Thanks a lot, Elizabeth and colleagues, for organizing this workshop. See you soon for the next one. That it's a very interesting intro about statistics. So let's keep our learning path very, very, very productive. In the next days, we're going to upload the videos, but also the workflow that Elizabeth was developing in our GitLab repository. So basically, you can redo the entire development by yourself. Thank you, and have a nice evening.
Thanks everyone for joining.
Thank you. Bye-bye.